Mr. Corsi here. Here's a vector question. We're asked to find the magnitude of the vector with these components. The result we'll be looking at and using is the following. If you have a vector with components a, b and c, then the magnitude or length of that vector is the square root of a squared plus b squared plus c squared. There is a reason for that in the x and y and z axes. If you have a vector v, then it'll have an x component, a say, and a y component, b say, that forms a right angle there, and a z component, c say, that's another right angle there. There's right angled triangles here. Pythagoras' theorem would give you this length here being a squared plus b squared, and then Pythagoras' theorem in this vertical triangle, this side squared, which would be a squared plus b squared, not the square root of a squared plus b squared, it's the actual length of it. The square of that's a squared plus b squared plus c squared, square rooted, to give you that. So the length of this line is actually the square root of a squared plus b squared, coming from this line, plus c squared, coming from this line. So they're all right angled triangles and using Pythagoras and so on. If you didn't understand that, it doesn't matter. Remember this formula. So in this case, the magnitude of r will be the square root of 24 squared plus negative 12 squared plus 8 squared. And we are privileged to be allowed to use calculators in this paper. So let's try that. 24 squared plus, now negative 12 squared is the same as 12 squared, 144 in both cases. So there's your 12 squared plus 8 squared, 64. There's 8 squared. So let's work out that. That's 784. And now we need the square root of 784. And what does that come to? 28. That's exact. 28 units. So that's Mr. Corsi signing out, and thanks for watching this video.